Good day all, I am Victoria Nibili. Welcome once again to another tutorial sponsored by Ingressive for Good in partnership with Zuri. Yeah, so what are we talking about today? Today, we're going to be talking about programming languages. Yeah, introduction to programming languages. Yeah, so in this tutorial, I'm going to be covering three things, right? What is computer programming, types of computer programming languages, and then some important concepts in programming. So, what is computer programming? Well, computer programming, also known as coding, involves writing well-structured instructions for a computer to execute. These instructions has to be detailed because the computer does not have a mind of its own. So, comparing to the real life, for example, you wake up in the morning by 10 a.m. and then you want coffee. What do? You stand up, go to the kitchen, boil water, add coffee to a cup, add milk if you want, and then your coffee is ready. So the same way, the step-by-step process, the way you went on ahead to make that coffee, that's the same way computer programming works. So, right, you have to write your code in a well-structured manner, and it has to be detailed. You cannot miss any information because the computer does not have a mind of its own. If you are giving the computer a set of instructions and you forget to tell the computer to add A plus B, the computer will not think for you. It will not think and just add A plus B by itself. If you forget to tell the computer to add A plus B in your set of instructions and you want it to add A plus B in your set of instructions and you forget to tell it, then I'm sorry, the computer will not actually do that for you. So when it comes to computer programming, any code you're writing has to be well structured and detailed enough for a mindless machine. Now, what are computer programming languages? First of all, what is a language? So, right, a language is a mode of communication that is used to share ideas and opinions between people. So, just the way we communicate, we use languages. For example, now I'm communicating with you using English language, right? This English language I'm using to communicate with you, I understand it, you understand it. I'm using it to pass my idea. It is a mode of communication. That's the same way programming languages are. A programming language is a computer language that is used by programmers or developers to communicate with computers. Computers only understand machine languages, that is, languages represented by zeros and ones. Now, computer programs are a set of instructions written in any specific language, like C, C++, Java, JavaScript, Python, and so on, to perform specific tasks. But like I said, computers only understand machine languages, so it cannot directly interpret these languages, even if the computer programs are written in them. Hence, the need for what we call a compiler and interpreter. A compiler or an interpreter, right? So, what are compilers and interpreters? Compilers and interpreters convert a computer program written in one language into another language, usually machine language, which can be processed by a computer. So now after writing codes in, for example, let's say I write a code in JavaScript, the computer cannot understand it directly because JavaScript is an high-level language, it's not a machine language, right? And computers only understand machine languages, which is in zeros and ones. So what a compiler and interpreter does is a compiler or interpreter converts this programming language into the language that the computer understands, and then the computer can process the information and carry out the tasks you want the computer to carry out. Now, compilers and interpreters, they help us accomplish one thing. They help us convert high-level languages into machine languages, right? They help us convert programming languages into machine languages so that the computer can interpret them. But what's the difference between a compiler and an interpreter? A compiler translates an entire program at once, while an interpreter translates its one statement at a time. Hence, the compiler is generally faster than the interpreter. So both of them does the same work, but the compiler is faster than the interpreter in the sense of in terms of the approach of converting these programming languages into machine language. Now, programming languages are divided into two. We have what we call low-level languages and high-level languages. What is a low-level language? So a low-level language is a machine-dependent programming language. The processor runs low-level programs directly without the need of a compiler or interpreter. So the programs written in low-level language can be run very fast. Example are machine languages and assembly languages, right? So an example of a low-level language is a machine language, which is in zeros and ones. That one, you don't even need compiler or interpreter. The computer just understands this directly. While we have an assembly language. So, like what I said, a machine language is a language that has a binary form. It can be directly executed by a computer, while an assembly language is a low-level programming language that requires a software called an assembler to convert into machine code. Now, what is an high-level programming language? These are designed for developing user-friendly software programs and websites. This programming language requires a compiler or interpreter to translate the program into machine language. Example, of course, Java, C, C++, JavaScript, Python, and so on and so forth. These are high-level languages, and you always need a compiler or an interpreter for the computer to understand them. Now, it might interest you to know that a high-level language is user-oriented, while a low-level language is machine-oriented. The primary difference between a low-level language and an high-level language is that any programmer can understand, compile, and interpret a high-level language feasibly as compared to a machine. The machine language, on the other hand, are capable of understanding the low-level language. The machines, on the other hand, are capable of understanding the low-level language more feasibly compared to humans. So the high-level language, humans can easily understand it, of course. We can understand it feasibly compared to machine language. Machine language is only just in zeros and ones. We're just saying so many zeros and ones. So we cannot understand that now as humans. But when it comes to high-level language, the way it is user-oriented. For example, JavaScript, you can see words like for. You can get to understand it when you write your code, right? You can read people's code and understand it. So you can understand it compared to when you have machine language that are just written in zeros and ones, and you cannot understand anything at all. You're just saying zeros and ones. You're just saying binary numbers. So, important programming concepts. So there are so many important programming concepts, but I'm going to be considering just a few. We have about 6 here. We have data and information. We have algorithm. We have variables and data types. We have data structures. We have conditionals, loops, and recursion. And then we have big O notation. Data and information. So what is data? Data are a collection of values that do not have a specific meaning. These values may be symbols, numbers, letters, facts, and so on and so forth. An example of data is a list of dates. Now, we have two different types of data. We have analog data and digital data. What is digital data? Digital data is data that represents other forms of data using specific machine language systems that can be interpreted by various technologies. Devices that use digital data are devices like your computer, laptops, iPad, smartwatches, and so on and so forth. What is analog data? Analog data is data that is represented in a physical way. Example, sound. Analog devices include loudspeakers, some thermometers, and amplifiers. What is information? Information refers to processed data, that is, data with meaningful use. When data is interpreted, it provides context with which we can make informed decisions. Hence, data simply do not carry specific meaning, while information carries logical meaning. Also, data does not depend on information, but information depends solely on data. An example of this data and information is, for example, when we have a school and then we get the test score of all the students. That's data. That's one piece of data, right? The test scores of all the students. But then when you take this data and then calculate the average score of a class or the entire school, that becomes information. You have processed that data of test scores into information. You now have an average. So let's talk about algorithms. So an algorithm is simply a set of instructions for solving a problem or accomplishing a task. For example, let's say you want to cook and you get a cookbook. In that cookbook, they'll give you a set of instructions. Get this, get that. Step 1, do this. Step 2, do this. Step 3, do this. And you follow it accordingly. That process now is called an algorithm. And you are following that cookbook process, because you want to cook a particular food, let's say beans. You are following the process, boil water, wash the beans, put this thing, put everything, put crayfish. All those processes you are following can be looked at as an algorithm. And then the end result, which is the cooked beans, is the task you have accomplished. So an algorithm is a set of instructions for solving a problem or accomplishing a task. And there are things you should know. A good algorithm should be clear and unambiguous. It should have like one meaning. The input and input types should be clear. It should be practical, that is, it should be applicable and able to be created. It should be interpretable in any language, right? So an example of an algorithm, for example, let's say in JavaScript, we want to get the average score of two numbers. This is a simple algorithm. So we have step 1. An algorithm has to be explicit, right? You have to state everything well. So we have step 1. We have to declare 3 variables, A, B, and then another variable called average. And these variables are integers, right? Step 2, we get the inputs A and B from the user. Step 3, we equate average to A plus B divided by 2, and then we print average. This is a simple step-by-step process to get to solve the average of two numbers, to get the average of two numbers. Yeah. Now, let's talk about variables and data types. So a variable is actually a value that can change. From the name variable, it varies, it can change depending on conditions or on information passed to a particular program, right? So variables are used to store data that is likely to be reused or and be manipulated in a program. They provide a way of labeling data so our programs can be understood more clearly by the reader and ourselves. You can think of a variable as a data container which you call when you need the data that is in it. For example, a program that requires that users put in their first name or age. A programmer will decide to use a variable called first name or age because it is not fixed data. Now, what are data types? In computer programming, data type is the classification of data which tells the compiler or interpreter how the programmer intends to use the data. Data type also defines a set of values and a set of operations that can be applied on those values. In simple terms, a data type specifies which type of value a variable has. Example, let's say the value 4 and the value Victoria. Obviously, 4 and Victoria are of two data types. 4 is an integer, while Victoria is a string, right? Now, when it comes to 4, there are certain operations you can carry out on 4 that you cannot carry out on Victoria, right? So you can do calculations on 4, like you can divide 4 by something, add 4 to something, it will work. But when it comes to Victoria, you cannot add Victoria to 4 or add Victoria to another, or add Victoria, you cannot add Victoria to 4, right? So when it comes to data type, you have to make sure that you're using the right operations on a particular data type, else it will always give you type error. You can, for example, let's say the value Victoria now. Let's say the value Victoria now. You cannot say Victoria divided by 2. It will throw an error. It will throw a type error telling you that you cannot perform that operation on Victoria. So, for example, in JavaScript, there are different data types. We have booleans, undefined numbers, string, array, object, and so on and so forth. Right? So that is it for variables and data types. Now let's go to data structures. A data structure provides you with a way of organizing data, right? A data structure provides you with a way of organizing data to use them effectively and efficiently. Think of it as a collection of data that are related. Example of data structures include arrays, stacks, queues, linked lists, heap, trees, and there are so many others. Now, let me explain what arrays, stack, queues, and linked lists are. Now, an array is a collection of data or items that are stored sequentially. The values in an array are called elements and are of the same data types. While a stack is a linear data collection that only allows addition and removal of items in a last in, first out order. For example, we can think of stack as a stack of plates, for example, stack of plates. When you want to, when you have a stack of plates, you only get to remove the one you added last first, right? So it is in a first in, it is in a what? Last in, first out order. So the one you added last to the stack of plates is the one you're going to remove first from the stack of plates. Then we have queues. So queues is actually similar to stack, but this time it follows a first in, first out order. For example, let's say a queue at the bank. Let's say a queue at the bank, queue at the ATM stand. So the first person on the queue gets to leave the queue first. So it is first in, first out. Then we have linked list. A linked list is a sequence of items arranged in a linear order, all connected to each other. Since they're all connected to each other, definitely You can't just access data randomly. Data has to be accessed in order. Now, let's talk about conditionals, loops, and recursion. Conditionals. It is also known as decision control. It means a program will do one multiple alternatives based on if a condition resolves to true or false. For example, when making coffee, you can decide to add milk if you like it, else you can leave it. Examples of conditional statements includes if else, nested if, switch. When I mean nested if, I mean an if inside an if, right? It is nested. Now, loops. A loop is a programming feature that lets us repeat a sequence of instruction until a condition is met, which is the break condition, right? So we keep on repeating a set of instructions until a particular condition is met. Once that condition is met, the loop stops. So loops actually needs a break condition to stop. If the break condition is not specified, the loop continues to run for as long as your program is active. This kind of situation is called an infinite loop, which is very, very bad for your computer. If you run into an infinite loop, if it's not properly taken care of, your computer can crash. So when it comes to loop, we have two types. We have the for loops and the while loops. So both these for loop and while loops can be used interchangeably, but the for loops actually, we use the for loop more when we know how many times we want a particular instruction to run, right? So for example, let's say you want to make coffee. Let's say you want to make coffee for 90 students. Now we don't want to make coffee 90 times. For that kind of repeated process, since we know that it's 90 times we want to make this coffee, we can use a for loop. While loop, we use while loop when we don't really know how many times we want to run a particular want to repeat a particular process. So recursion. Recursion. A recursion is simply a program that calls itself until it gets to a base condition. A recursive function can call itself directly or indirectly. Now let's talk about big O notation. Big O notation is also known as time complexity. It defines the longest time it can take a program to perform an operation, right? Some common complexities are O1, ON, O log n, ON square. So O1 is actually the best. That's like constant time complexity. This one's like the lowest time complexity, right? So an example is when you try to access a value with its index in an array. It takes the same time over and over again, right? It is constant. The time is constant. Then we have ON. This is linear time complexity. It's the time depends on how many times you are doing something, right? That's why it's N, right? How many times you are doing something. For example, inserting an item into an hash table, or in real life, reading a book with N pages, right? If you're reading a book with N pages, definitely the time you use to read the book depends on how many pages are in the book. So if you're reading a book of with 2 pages, the time is reduced compared to when you're reading a book with 10 pages. So the time depends on how many times you are doing a particular thing, right? So the time increases as the input increases. The time increases as the input increases. Then we have O log n, which is logarithmic time complexity, right? For example, binary search in a sorted array. So as the input size grows, operation time increases, but this time it increases slowly. why we have on raised to power 2. This is quadratic time complexity. This is very, very bad. This is very, very bad. And normally we have this when we are using nested arrays. So we have arrays inside an array. It is actually very, very, very bad. It makes your computer program runs very, very slowly. So when it comes to big O notation, it matters because why? It talks about how long a program takes to perform an operation. So a computer program that uses the constant time complexity is better compared to one that uses the quadratic time complexities, right? So when writing code, you should try and make sure that we're using the best, we're considering time complexities, right? So instead of using nested arrays, you can use just use your array normally instead of using nested array. As much as you can, avoid using nested arrays. It makes your program run slowly, which is not so good. Thank you very, very much for listening to this tutorial. Once again, I'm Enibeli Victoria, and I hope this went a long way in adding to your wealth of knowledge. Thank you.